With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, in this question, frequency of series limit of Lyman and frequency of first line of Lyman and frequency of series limit of Balmer are given. You have to find out the relation between the three. So if I relate the frequency with the transition, right, so I will write as Planck constant time frequency is equals to change in energy. Right, so change in energy you could write 13.6 z square into 1 upon n final square minus 1 upon n initial square. Right, so this will be the relation between orbit number and frequency. Right, so you could see here already the frequency is directly proportional to n final square minus n initial square. Right, and if I talk about the series limit, right, so series limit, the electron makes transition from an initial infinity to some n final. Here you have to find out the series limit for Lyman and series limit for Balmer. So if I talk about the Lyman series, right, so for Lyman the n final is equals to 1 and for Balmer the n final is equals to 2. Right, so you can put the values now, and you know that the frequency is directly proportional to this difference, right? So if I say this frequency for the first case, that is series limit for the Lyman, so I will write frequency for series limit for the Lyman is constant. So let's say k is any constant. So I will write k times of 1 upon, for Lyman the n final is equals to 1, and series limit, if I talking about the series limit, right, so I will write here 1 minus 1 upon infinity, right, so it will be equals to k. And if I talk about the first line of Lyman, right, so I will write, if you see in the question it is given that the first line of Lyman series have frequency this, so I will write the frequency of first line of Lyman is equals to 1 minus, for first line of Lyman the n final will be equals to 2, so 2 square I will write 4, so it will be equals to 3k by 4. Very simple. Now if I talk about the series limit of Balmer, so these two were for Lyman. Now let's move to Balmer. So series limit of Balmer, I will write frequency is equals to k times of, now the final n will be equals to 2, so I will write 1 by 4 minus, since we are talking about the series limit, so I will write 1 upon infinity which is equals to 0, so it will be k by 4. Now you could relate, right, so if you see from the option, right, so in the first option the frequency in first case minus second case equals to the third case, so if you match, this is the first minus second and it will be equals to third, so yeah, this is true. If you see frequency for 1, 2 is equals to frequency for 3, so this is justifying. If I write k minus 3k by 4, it is equals to k only, and yeah, so the first option is the correct one. Now you can also check for the BCD. So for B, the frequency for the first case is equals to second minus third, so if you see the second minus third, the 3 by 4k minus k by 4, it will be equals to k by 4, right, which is not equals to k, so second is wrong. So further, if you also see for C and D, right, so for C and D also the equation is not justifying, so the correct option here will be A. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.